Okay, Mr. Gazza here, Notes 120. This is page 7. Now I crossed some stuff out, mainly because we're talking about weathering, what affects weathering. Exposure and time, they kind of made sense to me. The more exposed the rock is, the more it'll weather, as opposed to being deep underground. Makes sense. Time, the longer it's been weathering, the more it'll weather. I thought it was pretty basic, so I don't think we need to watch to write it down, but write this down. Copy this right now. Pause this, please, and copy this stuff down now. Okay, you should have this down. Differential weathering is when different rock types in one location weather at different rates. We're going to see a lot of this throughout the rest of the year, what this means for us in the real world, what we see. And it changes the sediments after the weathering process. So basically, this should be a little more angular. I mean, I kind of drew the angles on here. Please kind of do that because it starts out angular, a rock that maybe falls off a cliff from frost wedging or root action. It will fall into a river, let's say, and it gets smaller and rounder as it tumbles in the river, or maybe in ocean waves, it's smaller. And at some point, ions in water will be like dissolved in the water at some point. Some minerals do that easier than others. Quartz will take a really, 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 really long time, thousands of years, but it will happen. But basically, as time goes on, rock becomes smaller and rounder. But that's also pretty basic as well. At the bottom here, we have soil. You may know it as dirt. We're going to call it, technically we're going to call it soil. And let's talk about that. Soil. So here's a picture of them studying the soil. What I really like about this is you can see the difference. Hopefully you can see this in this picture. Here's the grass up here. This top layer, which looks to be maybe a foot, 10 inches, is definitely browner. As you go down, it gets redder. And so maybe you can just see the difference in composition of layers of soil. And sometimes this soil layer could be an inch thick or it could be 6 feet thick. It depends on the location. And basically this is how it works. Please pause this and copy this down now. Okay, soil is a mixture of weathered rock, organic matter, water, and air. So, organic by weathered rock, it really means sand, silt, and clay are the real small components of soil. You may have some rocks in there, but it really means sand, silt, clay, and organic matter, things that were once living. What do I mean by that? I mean things like dead grasses and leaves and sticks and twigs, dead worms, worm poop, things like that in the soil. That usually tends to be good for growing crops, any sort of vegetation in soil, and that's what we're interested in. We need to eat that. So soil is really important. And soil forms, people don't think of it as forming. It forms very slowly. It forms as a result of weathering and biological activity. And really depends on climate conditions and a lot of other conditions. But in general, we say 1 inch of soil. The rule of thumb is about 500 years for a 1 inch of soil to form. So that's a really long amount of time. So think about wind blowing that soil away off a farmer's field, the top 6 inches of soil being blown away on a farmer's field. You know, that represents about 3,000 years to form. So things like events like the Dust Bowl, we have a lot of wind erosion of valuable soil and farmland. That was really very damaging, much more damaging than you would think. We tend to take our soil resource for granted, but people in the world of agriculture and farmers, they know that's their main natural resource that they need to grow food or have livestock. So this is here. This is supposed to represent limestone. It's not a brick wall. And as time goes by, the rock weathers, and when you're going to get broken down into pieces, maybe you get some vegetation growing maybe in the cracks. So now you have the vegetation. It's really the biologic activity, vegetation and animals, worms, things like that, that add to the soil here. And then it breaks, it really is not breaking it down so much as this layer is getting thicker. You have more organic or biologic activity and the soil gets thicker. The one thing I want to point out is that as time goes by, soil tends to layers get thicker. In addition, the soil layers get thicker as time goes by due to more biologic activity. The more biologic activity, the more soil will form, or the faster soil will form. And what you tend to have is that the closer you are to the surface, the more organic matter there is. The surface is where the plants, trees, bushes, leaves are all exist, and then a lot of the animals in the soil, think of worms, bugs, things like that, are in the top layer. So there's more organic layer matter towards the top. Okay, and then on the next page, we're going to skip some stuff here. This shows you there are different layers of soil. Usually the top layer has the most organic matter, best for growing, and it can go down. You end up at bedrock at some point. Sometimes it could be 60 feet down, or sometimes it could be 6 inches down. Okay, crossed out a lot of stuff here. Please pause this, copy it now. Okay, organic matter in soil is called humus. All right, and I crossed some stuff out just to adjust this. More organic activity that exists at the surface, the faster soil will form. Know that fact, that's key. And the longer soil has been forming, the thicker the soil layer. Usually that makes sense, unless there's been some kind of erosional event to take it away. But barring that, more time, thicker soil layer. I'm going to stop this episode now.